Welcome to Brain Vision.
In this question, it has been given that a program has 4,10,000 instructions and there are 4 instruction classes in the program and each class required a certain amount of clock cycle to execute. Okay, so we have instruction class, clock cycle per instruction and number of instruction. Okay, in the first part, if the program execute time, okay, so time is given to be 3.14 second. What is the clock cycle of the computer? So in this case, we need to find out the clock cycle of the computer and at what frequency does that computer run. So I will find out the total clock cycle will be equal to, so this is per instruction clock cycle which have been given, and here we are having total number of instructions, so we need to multiply. So 75,000 multiplied with 6 plus 92,500 multiplied with 8 plus 1,30,000 multiplied with 10 plus 1,12,500 multiplied with 8. So total clock comes out to be 33,90,000. Okay, so this is the clock of the computer. Okay, so this is total clock basically. We have to find out the clock cycle time. Okay, so clock cycle time, which we have been asked here. So this will be given by 3.14 divided by this total clock. So 33,90,000. So it comes out to be equals to 0.926 microseconds. Okay. So this is the answer for this part. And in the next question, we have been asked out the clock frequency. So clock frequency. So it comes out that this is equals to 1 point. It will be 1 over clock time. Okay. So it is 1.08 megahertz. So this is the required clock frequency. Now let's move to the next part. In that next part, what we have been asked, it is given that assume that as a part of the 41 lakh instruction of the program, 30% of all loaded instructions are immediately followed by an ALU instruction that uses the data that was uploaded. Okay. To speed up this program, the architects are contemplating adding a new type of instruction. This new instruction will replace the previous 2 instruction sequence. It will take 9 clock cycle. Will this change offer any speed up over the original design? If so, how much? So let us see what we have been given in the next part. So let me write here. So I will write down 30% of the load instruction we are considering in this case. So for this, what does that mean? 1,30,000 multiplied with 30 divided by 100. So this comes out to be equals to 39,000. Correct. So I will now write down new load instruction count. New load instruction count. So that will be given by 1,30,000 minus 39,000. So this comes out to be equals to 91,000. Then I have to find ALU instruction count as well. So ALU instruction count. So it comes out to be equals to 1,12,500 minus 39,000. So it comes out to be 73,500. Okay. Then I have to find out new added instruction count. So this will be equal to 39,000 only. Okay. Now if you find out the total clock in this case, so it will be 75,000 multiplied with 6, then we have 92,500 multiplied with 8 plus 91,000 multiplied with 10 plus 73,500 multiplied with 8, and then we have 39,000 multiplied with 9. So adding all of them, we get 30 lakh. 39,000 clocks. Okay, so this is the total number of clocks. So number of clock has increased. So I will say that yes, it will speed up. And how much it will speed up, that also we need to find out. So I will find here my speed up is equals to 33,90,000. It was initial and now we have 30,39,000. Correct. So this is 39,000. So it comes out to be 1.115. Okay, so by this amount it will speed up. Now let's move to the next part. If there is any speed up, explain why, and if not, explain why not. Okay, so let me write down the reason for this. So in part C, we can see that speed up is there. So it is speed up because it takes lesser time. It takes lesser time to execute than the previous one.